Hi everyone, I'm going to give you a quick walkthrough of the Disguise virtual production features and the cluster rendering and how this all comes together to a pretty exciting offering. So what we're going to cover today is a brief introduction to the Disguise Designer software, and then a look at cluster rendering and how cluster rendering can be used to turn Designer into an incredibly powerful virtual production tool with the power of Unreal Engine in the background. So what we're going to do this, I will open up a new project in the Disguise XR branch. So I'm just going to call this demo video, and then I'm going to open it. And when I open it, it's going to launch up. Disguise is a product that's designed to allow people to imagine, create and deliver spectacular live visual experiences across all sorts of different sectors. So whether that be the film and TV industry, the theatrical marketplace, concert touring, live events, fixed installations on buildings, the common theme with everywhere that Disguise is found is that it's creative video mapping. So it's mapping of video used in a creative way to create amazing experiences. And that can be accentuated significantly by the use of real-time content engines. So we've been working on this amazing workflow to make use of the cluster rendering capabilities of Unreal Engine to really expand what's possible with the Disguise software suite. So as the Designer software starts up, what you'll see is that every project with Disguise starts the same way. We have one projector, one man, and one screen, and that's the basics of a Disguise project. You'll see immediately that it's a 3D simulation engine, so we have a 3D understanding of the world, and we use that to communicate visually what's happening within this space. Today we're talking virtual production primarily, so I'm going to remove our projector and projection surface. I'll do that just up here. Go here, remove my projector and projection surface, and then I'm going to add in a LED screen. All of our objects in the Disguise world are represented by meshes, 3D meshes, object files generally, and I can pick and choose from a pre-selected library of those. So if I want a simple concave screen, I can select that, and then I can enter the dimensions here. So let's say we're going to do a 16 meter by 5 meter screen. I'm going to elevate it to 2.5 meters, and then I'm going to push it backwards by 6 meters to give us a nice curve on that screen. In fact, we could even go a little bit further than that. Let's go 12 meters. So we've got a nice curved LED volume here. Now, it doesn't have to be a single screen. We could also place in a floor, a ceiling. We could add in some DMX controlled screens. You can see that's all accessible from this menu here. For now, I'm just going to keep it simple with a single screen. And then I'm going to add in a camera. So Disguise allows me to create cameras, and those cameras see our virtual world. And that allows me to simulate camera shots and set up exactly how that camera behaves. So in here I can set the field of view, I can define that, and then a little further down I can put all of the lens parameters in. If I do have any other detail about this, for example a tracking source, I can select that in here, and then I would have the tracking data feed into this camera as well. So we have now a camera and an LED screen. We can then combine those through something called an MR set, and the MR set is basically just a link of the screen and the camera to say that the two are going to work together. In film context, this is just a one-to-one relationship, or a one-to-many if we have many screens. If we're working in a broadcast context where we're often dealing with cut cameras, then we can actually use a controller here to input control data, and that will take the tally data from the vision mixer and turn that into camera cuts in the Disguise world. This is incidentally where we also access many of our delay tools for calibrating delays and things like that. So now we've got the basics of our virtual production setup in place. Let's put some basic content down onto our timeline. So I can right click in the timeline and add for this first demo just a very simple video layer, and I'll go in and select a test card. And I'm going to map the test card using our mapping property to the LED screen. And when I do that, it maps out to the LED screen. Now we can see at the moment this is incredibly low resolution, and that's because my LED screen is 256 by 256 pixels. So I can define the pixel resolution of that screen as well. So if I know, for example, that it's 16 meters wide, and let's imagine we have 192 pixels on a tile, and therefore multiply that by 2 because the tiles are half a meter, and it's 5 meters high. So that's my resolution of the screen with 192 pixels on the tile. And in fact, the disguise simulator will show me accurately every single pixel. So if I apply a pixel mask like this, I can zoom into the screen, and as I get closer and closer to the screen, every pixel will actually be rendered as an individual pixel. And that becomes important when we're using this for simulation to show, for example, will the shot be crisp, or is it likely that we'll see the LED grid in camera? So we can preview that from the camera's viewpoint as well. Now obviously with this nice lens we don't have any problem with that, but if we had a very narrow lens, or if we were much closer to the LED, we may well start seeing pixel grids, and the simulation will show us. So now that we've configured our LED screen in the project, we can set up the outputs. Disguise separates the content canvas from the outputs, and this gives us great flexibility when it comes to mapping content across multiple servers, and even making technical decisions right up to the last minute without impacting the 3D creative of how things are actually going to sit. So this is the screen we use for that. It's the feed screen, and in here we can see our screens at the top, so my big LED screen, and then the outputs from our servers at the bottom. So I'm on a network with a v01, which is my editing machine that I'm running right now, and a v04 is a remote machine. We call it an actor, which is the machine that will actually push pixels out of its outputs to the screens. I can right click and choose add feed rectangle, and that'll add the LED screen as a rectangle that we can move around this space. And I can carve it up and move it between, say, two 4K outputs on the VX4. The VX4 has 4 4K outputs, so we can manipulate this as we need to. And we can even cut the screen up and split it between different outputs as needed, or even different machines, and that will just automatically work. Disguise figures out which videos to play out of which outputs, which streams to run, and so on. This interface is also where we apply genlock, modify any EDIDs, settings, configurations on the outputs, and then we also can manipulate refresh rates and things like that from within this interface. So it's a powerful system, and this really enables us to be incredibly flexible when we arrive on site. Now, we're not here to look at a test card, we're here to look at some content coming from Unreal Engine. So what I'm going to do is just jump to my Unreal machine. Now on this Unreal machine, I've got 426 installed, and I'm running the cluster rendering plugin. So in the plugins folder, I've dropped the Disguise RenderStream plugin, and then if I open up the Unreal project, I'll show you the configuration of the plugin. So we'll just open this up and let it sort itself out. Just to explain, as this does open my setup here, I've got 3 rendering nodes, which I'll be using for actually rendering to the screens in the Disguise environment, and then I have a 4th machine that I'm using as an editor, and that will also be the main machine, so that's going to host the multi-edit sessions and things like that later on when we get into that. So as you can see, this lovely resource just became available in the Epic Marketplace, and we've got it up and loaded into the Disguise environment. So if I jump into project settings, in RenderStream, we just have one setting now, generate scenes from levels. If I enable that, it's going to split down my levels and allow me to toggle each level on and off from the disguise timeline. With it switched off, it will behave like a traditional composited level in Unreal. So right now it's just taking the visibility of these two levels and showing me the daytime lighting. So the only things I need to do to make this work with RenderStream is to attach an object to one of the cameras in the scene. So I'm going to find camera actor 20. That's the one that I know has a pretty nice view right now. This is camera actor 20. If I do this, I can snap to it so we can have a look at that view, see what that camera is doing. And then I can add component, and here I can add a RenderStream channel definition. So RenderStream channel definition tells Disguise and Unreal that this particular camera is going to be visible to Disguise, so it's going to make it available as a keyframeable thing and a feed in Disguise that we can pick up and we can manipulate. We can then define the default visibility of objects. So right now I want all my objects to be visible, so I'm just going to set this to visible. This is really useful if you're working with augmented reality and you want to just make a couple of objects visible. There's a second object component type that allows you to add in the channel visibility, and if I pop this in, I can set whether this object is visible or hidden to that camera. So I can toggle this on a per object basis using this visibility component. I'll just take that off, we don't need that right now. So I've got a channel set up, and that channel is this camera actor. So that's actually all the configuration that's needed in Unreal Engine. Now the big powerful thing here is that we can quit out of Unreal Engine because Disguise is going to do all of the startup and configuration for me. So I've got my project built out here. It's stored in my RenderStream projects folder. Let's go back to Disguise. So in my Disguise system, I'm going to go and add a section in my timeline for RenderStream. And when I do that, you'll see now that the RenderStream layer has changed a little bit. What we've got here is the asset property, and this will auto-discover all of the assets on the servers on the network. So obviously we've been playing quite a bit on these machines. I'm going to use the Downtown West project, that's the one that we were just loading. And then I'm going to create what we call a pool. So the pool is basically a list of the machines that we want to work with. And if I go in here, I'm going to select 220, 221 and 222, which are my three RXs that I'm going to use as rendering nodes. And then we can create what's called an assigner. And the assigner basically lets me look at the content and decide how it's going to behave across these machines. I'm going to actually tell the network that this machine here has the main copy of the project. That's useful because we now have content syncing and we need to know where to sync from. So I've just defined that here. The RenderStream channels that we set up in Unreal are now visible within Disguise here. So I can pick that up and I can see that coming through. And then what we can do with that is we can assign that to various different roles within the network. So these assigners take the role of configuring all of the different information about exactly how this content is going to behave. So in this case, I want to change it to use RenderStream uncompressed. I'm going to run that at 10 bits, and we're going to add some alpha into that as well. I'm not going to play with the splitting strategies and padding yet, but we can do that a little bit later on. And the other new thing that we can play with is the mapping. So the mapping now is a property of the, it's a multi-channel map, and the multi-channel map has a channel for each of the camera objects that we set up in Unreal. And those can be mapped out to the various different mapping types within Disguise. So if I set this all up, Then I can go into this render workload. So I can now right click on my workload and choose sync. That will take a copy of the project on the main machine and push it across the network to all of the render nodes. So you can see 55210, which was the machine I was on earlier, has pushed a copy to all 3 of the remote nodes. So I can jump into the multi-channel map, and in here we can see the camera actor that I created in Unreal. It's been automatically created by RenderStream, and I can choose a mapping in Disguise to map that to. So I'm just going to map that to the LED screen, and then I'm going to go in and ask it to start up that workload. When I do that, Disguise will reach out to the rendering nodes, and it will start up an instance of Unreal. It will be ready to run, and then it will start receiving streams across the network and bring those across into the receiving machine, which in this case is this VX1. So it's just kicking off the startup. Sometimes the first startup can take a little while, and that's because the Unreal Engine is spinning up, and sometimes, depending on the settings you've changed, it may need to compile shaders and adjust the behavior of the content in certain ways. But you can see that we do now have a stream up and running from Unreal Engine into Disguise, and this is actually a stream composed of 3 nodes. So if I jump into the advanced window here, I can see that I have these 3 streams running, and I can open up the status. Each of them is running at 55 frames a second, and they're rendering 1/3 each of this 6K by 1K image. And we can see the various different fragments here. So this is the first fragment, this is the second one, and this is the third one. So in its most simplistic form, we now have a stream coming from Unreal Engine, and we can start manipulating that, playing with it, and adjusting it in various different ways. So the next thing we might well want to do is to be able to network edit this Unreal Engine session. So to do that, we're going to have to go into Unreal Engine and enable multi-editing. So I'm going to stop the cluster. That stops the streams. And then I can jump back to my editing machine, go back into the Unreal project, and I'm just going to make sure that we are enabling multi-editing. So that's enabled from the plugins, and we can just go in here and say multi-edit, multi-user editing, yes, and then restart. Now because the nodes which are doing the rendering are nominally headless, we need to be able to tell them to automatically join the multi-editing session, because we're not going to be able to go and manually do that from those nodes. You can, of course, go in and tweak this behavior yourself as you build out your project. But what I'm going to do is just enable multi-user, enable the toolbar button, and then put in the default server ID, 55210, and a session name. We're going to say demo video. So I've entered a default server name and session name into the project settings. Unreal's just asking for a restart, so we'll do that quickly now. And once it's restarted, we'll save everything, and then we'll push that change across the network. So we'll sync the project to all the other nodes. So just save everything. And now I'll go back to Disguise and hit sync. It's going to kick off some more sync tasks. And then the only other thing I need to do is I need to start the multi-user server on the editing machine. So the multi-user server will sit there, and it's going to exist and wait for connections. So now I ask the cluster to start up again, and this time we are going to see the cluster join the multi-user session. So not only do we get the stream into disguise, but we also now have those machines all connected and controllable. So I'm going to go on my Unreal machine back into the editor, and remember that we also set that editor to auto join the session. So once the editor joins in, we'll then be in a place where we can actually see the stream up and running, and they've all joined the same session. So I can grab an object, for example this plant pot, and relocate it. Okay, we probably should have moved the plants as well. Let's pop that back. So everything I do happens live now, and this means that we can make some pretty substantial changes to the Unreal project while it's actually up and running. For example, if I unlock my level here, I can go in and find the post-process volume, and then within that I can go and tweak behaviors like exposure. This is actually an important point that you may see some seams in the content here, and that's because the exposure is being calculated on each node individually. That's not the behavior that we want. What we want is for the machine to, or for all the machines to expose the same amount. So the way to do that is to use the manual exposure, and if I dial a manual exposure, suddenly my scene becomes a lot less visible. There are probably some other things going on in this particular scene, so we could play around, and most likely located within the post-process volume. So multi-editing is hugely powerful and has great benefits for the workflow. What we can also do is we can also set up multiple streams coming from Unreal Engine. So the way that we do that is exactly the same way that we had that single stream earlier on. So if we go back to our camera actors in the scene, I can pick another camera actor with another viewpoint that we like. Maybe we'll take this one looks quite nice, and add our RenderStream channel definition to it, and now that will become a usable channel across the nodes as well. Now to do this we do have to stop and start the cluster with a sync as well, so I'm just going to save everything. Obviously we've made quite a few changes there, and stop the cluster, sync. I can open my sync task just to see that pushing through, and we'll see now that my mapping has gone red. That's telling me that there is another channel available, and we can see it there, Cine Camera Actor 14. I can hit create channels, and then I can go in here and I can assign a mapping to that. So we have the cluster set up here, and we can create a multi-channel map. So here the multi-channel map has two feed maps attached to it. Feed maps are mapped to the left and right of the screen to two camera actors in Unreal. And now when I hit start, Disguise will go out and launch the cluster on two nodes and get that running across the left and right part of the screen. So the streams are just kicking in, and once they're there, we'll see the content mapped out to those two mappings. And there we go. So there's a lamppost just sitting on the dividing line, but if I zoom in there, you'll see that we do actually have two totally separate streams of content coming in, both running at decent frame rates and looking really, really good. This is in a multi-user session, so I can also go in and play around with lots of settings. So for example, I can turn bloom on, and let's just go for a really accentuated bloom right now. And we'll see that reflected instantly on the nodes when I do that. Can also go in and turn on lens flares. Lens flares always look cool. So again, just a quick play on the nodes and we get that that behavior reflected live on the outputs. So this is a really powerful creative tool. Now we can start manipulating our 3D world in lots of creative ways and seeing it live on large volumes. Again, this doesn't have to be LED for virtual production. This could be a projection mapping, it could be a theatrical show, whatever it is. The content is coming through the disguise system, so we can use it in lots of different creative ways. If we are dealing with a virtual production setup, it's more likely, rather than static content like this, that we would want content to be mapped from the camera's frustum. So to do that, what we would do is stop the cluster, jump into our mappings, and rather than using feed mappings, I will use a spatial map. Now a spatial map will render the content from the perspective of the camera relative to a 0 point that's defined within the mapping. So once that starts up, and you'll see now that all 3 workloads are kicking in. That's because we're doing a single node, a single channel, so we can use all 3 nodes to work towards that workload. And then we'll see the content projected from the eye point of that camera. So if I open up that camera's interface, I can move that camera around and go scout that scene and line up our shot as we want to. Maybe pull back a little bit. So again, this is all real time. I can jump in and switch the level to nighttime, and everything will just dynamically update in the scene. So a common request for virtual production is to have content not just inside the hero camera, but also outside the frustum. So to achieve that, what we want to do is we want to set up a second stream from the same camera actor in Unreal. So what I'm going to do is add another camera to the disguise stage, which we're going to call out of frustum, and we'll just pop that in the center here and hide up. We're going to widen its field of view so that it can see the whole of the scene. So just give it a 90-degree field of view now. So I can jump into my multi-channel map, add my out of frustum perspective map, which I've configured to be 1920 by 1080, and I'm going to put that above the MR set. And then when I start my cluster up, we'll get 2 streams, and those streams should stay in sync, but the hero camera will be dynamic and able to follow tracking, while the out of frustum camera will stay stationary as you'd expect it to. So we'll just give those a second to spin up. And there's my 2 scenes, and then I've just logged into the editing session. So as my hero camera moves around, we get a new perspective on the scene. It's all dynamically updating and working very, very nicely, whilst the out of frustum content is there. And I could obviously tweak the position of that camera just to make sure that we fill the full volume as we want to. Incidentally, because this is disguised content mapping, this could also be mapping to DMX pixels, this could also be driving screen brightnesses, projection pixels, whatever it happens to be. That doesn't impact on the final decisions there. So that's a really powerful way of using the RenderStream channels capability. So let's take a quick look at some of the other new options that have been added to the latest RenderStream beta. So here we can see in the cluster assigner that we can now create individual channels, and each channel can have its own assigned behavior. That's incredibly useful because it means that we can do things like have certain channels running with RenderStream compressed while other channels run with RenderStream uncompressed. And we can change the bit depth and alpha behaviors of individual cameras or channels. And we can also make use of these new settings for splitting strategy. So the overall splitting strategy has been moved up to here, but you can now request RenderStream to create a overlap in a number of pixels. That allows you to overcome simulation imperfections where maybe a particular simulation is not deterministic and you need to mask that. Those two streams will be blended by RenderStream when they're received into the compositing server. And padding. And the padding is there to allow you to request RenderStream to render additional pixels outside of the used frustum. That's very useful if you need to have screen space effects that are, say, missing an object because it's not within the visible space. So you can increase the padding to compensate for that. And then there's also a weighting, so you can attribute a weighting to a particular channel viewport, and that will then use that when assigning the pool to make sure that the higher weighted objects receive the most power from the cluster that's available. So these are all available under the assigner. The other new setting that we've just added is the ability for RenderStream to automatically kick off the workloads across the network. So you can do that just with this manage RenderStream workloads tick box. If that's ticked, then RenderStream will automatically start the cluster when you open Disguise or when the playhead needs that particular cluster to be available. At the moment, that's the only behavior. It only starts the cluster. It doesn't automatically stop them when they stop being needed and anything like that. But over time, we will be merging and building out that feature. So if you do have thoughts on what else you'd like that behavior to be, let us know. One thing you might well want to do in virtual production setups is to add augmented reality objects into the streams. Augmented reality can be sent using RenderStream by adding in an additional RenderStream camera and then using that camera to send specific objects. So in my project, I have an AR camera that I've added in. That camera is looking at the scene, and I've got a RenderStream channel definition attached to it. I've set the default visibility there to hidden rather than visible. Now what I'm going to do is grab from the content library a new asset. Let's just grab a prop. I know there's some bits and pieces in this project. Let's choose the statue of the eagle, and I'll just drop that in here. So we're going to place this object into AR so it will be rendered to the front plate. So what I'm going to do to that is add component, visibility, the RenderStream channel visibility, and to the AR camera I'm going to set it to force visible. So that means that this object will be visible to the AR camera. If I want, I can also make it force hidden to the other camera actors, but for now I'll just leave that as it is. So I'm going to save and sync my project, and then we can see this stream coming up in Disguise. So now jumping back into Disguise, I jump into my multi-channel map and I can map the AR camera to a front plate version of the MR set. I've also got my outer frustum and my hero frustum MR set mapped to the same cine camera. So now when I start up the cluster, I'm going to get 3 workloads running across the network. Obviously my hero frustum on top of the outer frustum, and then the AR plate coming in as well, and that will allow me to see objects in AR as well as in the backplate, and we should see those spin up any second now. So I added a few more people, and you can see that from the camera's perspective we're seeing the hot dog cart and the eagle in front of the scene, whilst they're also being rendered into the backplate, and as the camera moves, all of those track nicely together. So that's just another workflow that's available within these amazing new workflows that are being powered by cluster rendering. Hope you like this. It's very exciting and love to hear your feedback. And if you do have any thoughts and questions, don't hesitate to let us know.